Hello, ladies and gentlemen. Root Beer here with question number 24, our second last question on the 2010 Pascal math contest. So, let's take a look at what question 24 has to offer. A sequence consists of 2010 terms. Each term after the first one, the first is one larger. So each term after the first is one larger than the previous term. The sum of the 2010 terms is 5,307. When every second term is added up, starting with the first term, whatever it may be, and ending with the second last term, because we got an even number of terms, the sum is... Okay, good question. Good question. All right, so each term after the first is one larger than the previous term. This is what we call an arithmetic sequence. Every term differs by the same amount, or every pair of consecutive terms differs by the same amount. Now, I don't know how we're starting, but we start with some number a. Then we've got a plus 1, a plus 2, and we keep going all the way up to a plus 2009. Now, not 2010, because this is technically a plus 0. And from 1 to 2009 is 2009 terms. And then this just gives us our 2010th term. Okay? So it's not the most obvious fact, but it is something to be comfortable with when you're writing the latter questions on a contest. This shouldn't be something that is really puzzling you right now. That why do I only go up to 2009 if I want 2010 terms? Okay? But there we go. So these are our terms. And when I add them all up, I get 5,307. Okay. So what is there to do? Can we figure out A? Well, absolutely we can figure out A. But more than that, what do we actually want? We want to know the sum of A plus the next term, A plus 2, and then we want every other term all the way up to A plus 2008. And so while we might want A, okay, we might want to figure out the first term. If there is a shortcut that gets us just the sum of these numbers down here, we need to go for it. Now, there doesn't seem to be any such shortcut right away. But, yeah, I think we can figure out what A is. So we've got A plus 1 plus A plus 2. We just keep going up to A plus 2009. Now, what I'm going to do is I'm going to separate the A's. How many A's? Well, there's 2010 of them. 2010 A's, and then what have we got? We've got 1 plus 2 plus all the way up to plus 2009. Okay. Now there is an expression for sums like this, the sum of the first so many natural numbers. And it's an expression that if you're serious about math contests, you want to become familiar with it if you're not already familiar with it. Sum of the first n natural numbers is n times n plus 1 over 2. So my expression for 5,307 is 2010 A's plus 2009 times 2010 all over 2. And I can use this to figure out A. Now, just a little side note. I mentioned arithmetic sequences before, and so, this seems as good a time as any to point this out. Arithmetic sequences all have the same difference. We call it a common difference D. So we start with some term A, and then the next is A plus D, then we add D onto that, then we add D onto that, and we just keep going. And if you want n terms in your arithmetic sequence, you'll go up to A n minus 1 times D. That's why we went up to 2009 if we had 2010 terms. And the sum of my arithmetic sequences, of the first n terms of an arithmetic sequence, has a nice formula. NA plus, and then n minus 1 n over 2 times D. So this is a nice formula if you're ever confronted with another kind of arithmetic sequence. This one here had D equals 1. Okay. And n being 2010, that's why we had 2010 A's, and we had 2009 times 2010 over 2. So just a little formula to have in your back pocket, a little thing to be curious about, and maybe investigate more arithmetic sequences on your own if you want to get very good at math contests. So our D is 1, so I'll just write times 1. Now 2009 times 2010 divided by 2 is a really big number. a ridiculously big number. So we get 2010A plus 2,019,045. Really big, but that's okay. We'll bring it over to the other side, so subtract that and add on 5307. And so I'll get negative 2,137.38 is 2010 times A. Now I'm just a little suspicious here. Did they not say they were integers? No, just terms. Okay, we don't need to have integers here. That's fine. And so we get an expression for A. A is negative 2,013,739. For a second there I thought, why did the 9 change to a 3? But that's because I added on 5,000. Okay. So that divided by 2010. I'm going to leave it like that. I don't really see how having a decimal is going to help me there. But now let's think about our new terms, the sequence that I need to figure out. Okay, A plus 2, A plus 4. Well, this is an arithmetic sequence as well. How many terms? Well, it's every other term, so it's half as many terms, and that means it's going to be 1,005 terms. And what's the difference between each term? Well, it's not 1. We're skipping over things, so it's 2. So the sum here, the thing that I want to figure out, is 1,005 times A. Hey, I know what A is. Plus 1,004 times 1,005 over 2 times my D, which happens to be 2. And I know what A is. It's negative 2,013,738 all over 2010. And 1,005 is just half of 2010, so we're just going to be left with a 2 on the bottom. So if I divide my 2 million, my negative 2 million, I get negative 1,006,869. And now the 2's here cancel out, so 1,004 times 1,005 is 1,009,020. So I just need to add those up, or take the difference between the 2 million numbers. Okay, and I get a difference of 2,151. So let's check if the calculator button presses were correct. Is that a possibility? It absolutely is. It's C right there in the middle. Okay. Now, part of me suspects there might be a faster way to do the question, a way to do it without figuring out what A is, but off the top of my head, I can't think of it right now. So if you find a way to do the question faster, by all means, please leave a comment, and also leave a comment if I've somehow screwed up some of the arithmetic here. But since I got one of their few answers, I really don't think I did. I think this is a good answer here. And how does this relate to the 5307? So it should be roughly about half of it, right? No, not quite. Interesting. Very curious. Very curious, this question. I wonder, I was about to end the video, but I wonder, A plus 1, well, that's just 2A plus a 1. And A plus 2, A plus 3, that's just 2 times the number I want to add up plus another 1. I can keep going like this. Actually, oh yeah, I think this is definitely a faster way to solve the question. So the last one here, 2008, 2009, is 2 times A plus 2008 plus another 1 for this 2009. It's not really a 2008. And so this is going to be 2 times... Oh yeah, this is much cleaner. I wish I'd thought of this at the start. So this is 2 times the terms I want to add up, plus a bunch of 1s. How many 1s? Well, I'm pairing each of my 2010 numbers. So it's going to be half as many, so 1005. So this should be 5307, and now if I just do 5307 minus 1005 and divide that by 2, oh, there we go, much cleaner. Much better way to do the question. I really wish I thought of that first, but maybe you learned a little bit about arithmetic sequences. I don't know. But that's question 24. That's 2 ways to do question 24. Certainly a fast way and well, a little more calculation, rearrangey way that I did first, but that's okay. Up next, we'll finish off the contest with question 25. I'll see you there.